So I'll quickly share the biopharma QMS solution over here, go over the overview, and I'll also talk about relevant experience that I have in this field, and I'll share my portfolio. All links will be in the description. Now, when it comes to biopharma QMS solutions, the data set essentially comes into the system in batches. So institutions like HMC and other providers of health related data sets, they mainly send it in batches. These data sets are not labeled, so we do not know whether a specific data set is a data set that complies or it's a risk. Right? It's just a raw data set that the institutions send. Now, our job is to analyze anomalies within these data sets. So, firstly, you would have to make sure you're complying with the regulations. So, any privacy related data like patient ID has to be kept a secret. So, over here, as you can see, I have hashed the patient ID, right? So, all the sensitive metrics, all the sensitive variables in the data set have to be kept a secret. So hashing is a good procedure to do that. Then we would go on to feature engineering. Now, 80% of the time for a machine learning engineer and someone who's designing these pipelines, 80% of the time goes into feature engineering. This is where you're scaling each of the variables so that the model can understand better, right? Because the model won't understand 37.1, 7.2 by itself. It will treat all of those, uh, like it will treat it differently. So we need to standardize these numbers into a representation that the model can understand and treat all features equally, right? So this would be the feature engineering stage. Then we would pick a specific algorithm. Now, our job is to detect anomalies, and the data set that's coming in batches is not labeled. So we need to essentially isolate the outliers. So as you can see over here, we have a data point that is far away from the cluster. So in biopharma data sets, mainly the data that's coming in is normal. It's actually pretty rare to have anomalies. So the data set that is in a cluster, we are going to assume that it is true. Now, new regulations can come out and things can change. However, we can design separate pipelines for that specific matter. Now, when it comes to the raw data sets, so most batches are expected to be normal, right? And the question we're going to ask is, does this batch look unusual compared to normal manufacturing behavior? So as you can see over here, most data sets are here and the outlier is over here. So it's easier to separate this outlier because it is further away from the cluster. It is much harder to separate something that's within the cluster. An isolation forest essentially works with decision trees. And decision trees essentially separate logic into two parts. So at each stage, you will ask a question whether the temperature is above 40, whether the pH is below 3.5. And you would, as you progress down the tree, you would ask questions. So each subsequent layer has a different question. And as you go to the right or to the left, it will indicate whether there is an outlier. Now, in machine learning, there is typically three approaches. We have unsupervised, unsupervised learning, and reinforcement learning. We can exclude reinforcement learning for now because it involves agentic work. You have to send an agent to a scenario and it learns, right? So that's not really necessary for this task. We'll be mainly focusing on supervised and unsupervised. Now, the batches that are coming in are not labeled, right, as we discussed before. So our focus would be to take algorithms that are unsupervised, that do not have a label, that do not necessarily require a label. So we will focus on clustering the data set, and then we would be drawing conclusions from there and detecting anomalies. So this would be the approach. And a little bit about my experience. So I worked at HNC. I've done an internship as a deep learning researcher at semantic segmentation. We did a lot of work with PyTorch over here, and I also have a certification Coursera from Andrew Inc. In Qatar University, I worked under Dr. Sumya Al Madid. The grade I got was A, and we designed a manuscript as well. This was a classification sort of a task, and yeah, so studied under Dr. Sumya Al-Madid. And at Curie, my internship is ongoing at the moment. So yeah, and it's related to material informatics on organic thermoelectric polymers. And if you click on this link over here, it'll take you to my complete portfolio, and you can have a good view of all my work that I've done that best complements the specific requirement of the project. Thank you. So this is a quick code demonstration of the algorithm. Here we have a data frame, a small CSV, which shows some variables. As you can see, the first three rows are relatively similar, and the fourth row is an anomaly. So our algorithm should flag the fourth row, and this replicates the data sets coming in from uh, companies like HMC because they send data in batches. It's not labeled, it's mainly unsupervised. So our algorithm here is also unsupervised. And I'll set it up. Model.fit. So here we want to fit the data into the model essentially. And we have predictions. So this is going to perform inference, and then we need to get the score. Once the score is calculated, we're going to add this to the data frame. Prediction score. Yeah. And for the last column, we're going to add status. And essentially, the model gives a number, so that's not always helpful. We would want a sort of a text description. So one would be, let's say, normal, and -1 would be a risk, right? So to run this, right? So as you can see, the first three columns, they're relatively similar. So the algorithm essentially clusters data points and picks out anomalies. So the fourth row is a little bit abnormal. As you can see, the temperature is much higher. The pH is relatively lower than the first three rows. Again, same with pressure, it's a little higher. Same with contamination. Thus, the prediction is -1. So for isolation forest, if it's a positive prediction, that means it is a not a anomaly, and negative predictions, it is suggesting that this row is an anomaly. So I'll quickly be sharing some of my experience. I worked at Qatar Computing Research Institute as an intern, machine learning intern. At QSTP, I did some work as an AI ML developer, and we used Azure and integrated REST API there as well. In Curie, I focused on material informatics. At HMC, I did some deep learning researchers' work on surgical semantic segmentation, and this was essentially medical computer vision work. I have graduated uh, as a computer engineer from Qatar University with a 3.5 plus GPA, and I am actively applying for master programs at universities in Qatar. So starting off with the first requirement, Python, I have done a lot of high-end projects in QU under various doctors, and I have extensive experience in this domain. I also have a Stanford certification on C++ on algorithms. Moving to the next requirement, machine learning. So again, I have a Coursera certification by Andrew Ng on deep learning over here. And at QSTP, I've done more machine learning related work. Similarly at Curie and HMC, as you can see. These are some of my best projects. So at QSTP, we used a VGG16 based student engagement classifier using TensorFlow. Essentially, TensorFlow was used here for easy deployment on Azure pipelines. And the aim was to take a pre-trained model, which is VGG16, and add a classification head over here to classify whether students are engaged or not engaged. And we went through the complete machine learning pipeline and used TensorFlow. The second project was with Tamar Al Said at Qatar University. Essentially, this was a essay scoring machine learning operation. We used PyTorch over here because for industry level work, we use TensorFlow for easier deployment and PyTorch for research work. And essentially, we had to score each essay. So this was a good exercise. And this was at Qatar University by Dr. Tamar Al Said. When it comes to data systems, I have been interning at QCRI under Dr. Michael Obitet. Here we are designing a data set for training LLMs on human-centric tables. I have done contributions over here as well. This is a project called Experiment Analysis and Benchmark HCT Question Answering. So I have contributed over here. And here is a video explaining my work. Again, the links to all of these will be in the description. So this is a pipeline that we are constructing at the moment, and we are targeting ACL as our conference. So this is some work I've done as well at QCRI related to data systems. And I also have a letter of recommendation from Michael Opitet, who is a research scientist at QCRI. We are doing some more work over here, as I mentioned, targeting ACL. So this is the second part of the QCRI project, and it's related to data systems. When it comes to dashboards, I have extensive experience over here too, trying to explain my work to professors. So Dr. Anas Abu Taha, he's a research scientist at Curie, and here we are working on material informatics specifically for organic thermoelectric polymers. These polymers have a lot of qualities about them, a lot of parameters, and we need to optimize certain parameters to find best polymers to test in lab, essentially, and machine learning accelerates this process. So from collecting papers to extracting them using agentic workflows, then obtaining the raw CSV, then performing explanatory data analysis, then pre-processing it, right? So filling in the missing values and then getting it ready for feature engineering. So we have two outputs here, a data set without feature engineering and a data set with a feature engineering. And then we would put it into a model and you can test it with any other model. Again, this is ongoing work right now, and we are in the process of completing a data set for the feature engineering part. So second, the other requirement is cloud and Azure. So over here at QSTP, essentially once these models were deployed on TensorFlow, we had to put it on Azure. The company I was working on was called EdGauge. It was an educational company, and essentially they wanted to monitor the behavior of students. And my role here was a AI ML developer, where I had to predict the mood, the behavior, the attention, and the engagement of students. And this pipeline had to be deployed on Azure because the company was using Azure for all of its services. And some exciting news and research and master applications. So I'm actively applying for master programs at HBKU, Qatar University, CMU to continue growing in AI ML research. I've also been selected for the QCI project called Parameter Space Model Merging for LLMs under Dr. Bill Kadir. Right? He's another research scientist at QCRI. And yeah, so this aligns with my goals for applied machine learning research.